This class will be talking about the DevOps pipeline from when the developer pushes code into GitHub, it gets built using Jenkins and deployed into our test environment. When it comes to incremental builds, Jenkins solves that problem. Testing, Selenium, consistency, that's where Ansible comes in. And we're going to study Ansible as well. And when it comes to dependencies, the way projects behave, now we have orchestration like Docker, Kubernetes, and we're going to study all that. So guys, DevOps is such a great field to be in. We solve so many problems, and you see why companies are willing to pay so much money for DevOps engineers. You'll be able to, as we go along, you'll be able to see why. So this is pretty much what was happening before DevOps. You know, you have a release and a deploy. Someone who just pretty much the developer just finishes with his code, you know, packages it, and just comes and hands it over to the operations team, right? It could be a system administrator. And then he takes it from there. So he just takes that, and then now he's worried. He's like, I don't know what this code is. How am I going to deploy it? And then that's already a trust issues right there. So you start seeing unpredictable issues that you've never thought that was going to happen. You know, there was no monitoring. Most systems, even to today, there was not monitoring. And as a DevOps engineer, monitoring is your best friend. You want to see things before they happen, right? And that's what DevOps brings in. Blame game. When the developer develops a code and brings it, and you, as a system administrator, you deploy that code, since there's no visibility and it breaks, now you're blaming that developer. Oh, you caused this, oh, you caused that. I had issues like that where, when, you know, back then when I was doing DBA, when something breaks the database, I'm blaming the developers. You know, I'm like, you did it. Like, why would you give me a bad code? And that happens all the time. So there's always a blame game. And this is one of the reasons why DevOps came into the picture. Let's see. So now that we have DevOps, this is kind of what we have. We have streamlined delivery. So, for example, if a developer pushes in his code, we as DevOps, we automatically build pipelines. You know, we use Jenkins, and that code is tested and deployed to a test environment. If it passes those tests, and then you can deploy that to production, and all that is done in an automated manner. So you don't have that issues of, oh, you're going to break a system, because if something breaks, it's going to break in the development environment, right? So you have production. So you're not worried about breaking production. And you're going to see that. And once it breaks, guess what? Your pipelines are going to send an email to that developer telling them that, oh, this code you pushed in, it just broke the database, or it just broke in dev. Can you fix it? He fixes it and he pushes it into Git, and the same process all over again with no manual intervention, guys. All this is happening while you're sitting on your couch and you're crossing your leg, right? Everything's happening. You as a DevOps, you've seen everything. Everything's in the pipeline. There's more collaboration. You know, there's monitoring. Like we're going to do Prometheus and Grafana for monitoring, where you can actually see what's going on behind the scenes. You can put alerts. So whenever a system CPU is high, you get that alert. Any kind of issues that you have that alert. So I think that's kind of what, you know, why DevOps is so valuable. And this, for example, this what used to happen. You know, before, I know Valerie, you could probably point that out. You know, companies used to, even now, some companies used to take 6 months to do a release. You know what I mean? So when I say a release, I'm talking about, let's say, for example, Christmas is coming, and Walmart wants to sell some Christmas-related things on their website. You know, it was so hard for Walmart to make those changes, right? Because first of all, they don't have any visibility. So they're scared that things are going to break. Secondly, they don't have a streamlined way of testing things on the go. So now they have to put all these different features in one release and then push it in. And guys, can you imagine what happens when you put multiple different changes in one code and try to release them? You get problems that you can never understand. You know, you can get problems here and there. And I think that's the main reason why DevOps is, because with DevOps, now you can do changes every single hours. Some companies, they do like changes every 5 minutes and automatically gets built, deployed. And if it passes, it gets pushed to production. Can you imagine how efficient the company will be if they're able to do that? That's why they pay you all that money. And we're going to see how we're going to do that throughout the class. So this is an example of a developer doing a waterfall model. When I say waterfall, I mean, what I'm trying to say is old school. You know, that's pretty much what waterfall is. That's the old school way of doing things. You have huge waiting time for code deployments. I was at my first company that hired me. They were telling me, oh, you're going to be a DevOps engineer, but pretty much they weren't doing DevOps. You know what I mean? So we were taking sometimes 2-3 months to do code deployment. And I told them, this is not DevOps. DevOps is being able to release codes as fast as possible, even every hour, or even every 5 minutes. If you're going to wait 2 to 3 months to release code, that's not DevOps. But there's so many companies out there looking for DevOps engineer, but you end up, just being in an environment like that. But who cares? That just means there's so many jobs. Even companies are confused what they want. And it's just how the wave, that's the hype that DevOps has. And as time goes on, from now to the next 5 years, to the next 10 years, DevOps is going to keep leading the way, because the changes that we do, the impact that we have on an organization is so big. You can work with startups. Startups, they need DevOps the most because they can't afford to pay system engineers, database administrators, and multiple developers at once. So they want a guy that can easily automate, right? That's and you know how many startups we have every single year? We have old companies that have been struggling with our old school way for a long time, and they need a change. Guess what? They need DevOps. We have medium-sized companies that are trying to compete. Guess what? They need DevOps. That's why every single day you go online, you're going to see a new opening for DevOps job. The first job I had, they had that position open for 1 year, guys. 1 year. Yeah, they couldn't get someone to fill it for 1 year. That's how much the demand is for DevOps right now. So yeah, so most of these visuals, guys, it's just so you can better visualize. So for example, one of the challenges is waiting for code deployment. And one of the solutions that we bring as DevOps is continuous integration with Jenkins, right? So that brings quick deployment, faster testing, speedy feedback. If your code fails, automatically you can send an email back to the developer and tell him, oh, the code you pushed in just failed, right? So guys, some of this is going to sound like difficult to understand. Some of this is not going to make a lot of sense. But if you can understand the concept of what DevOps is, once we get in and start doing the practicals, now you're going to see how all this is tying together. All this is coming together. For example, the pressure of, work, is explained here. DevOps just solves that problem because we focus on building code, no waiting time. You don't have to wait for new changes. I have guys now in my company that as soon as they finish something, even if at midnight when everyone is sleeping, if someone was working on the project and he pushes that in, it automatically gets built, deployed in dev. If it passes, deployed in staging. If it passes, automatically pushes to production. Can you imagine that? And I'm sleeping, I'm chilling. Even the developer doesn't have to do anything, guys. That's what we do, and that's why I'm telling you, being a DevOps engineer will be the best decision that you ever. If you can successfully be a DevOps engineer, you're set. And everything's going to keep going up, the demand, and with high demand means more salary. When I got in there, they were paying 120, 130. Companies were struggling to give 130. Now I'm seeing companies throwing 140, 150, just throwing it around like it's nothing, because the demand is so high, and it works with our favor. So I don't have any issues with that. So anyway, this is some of these slides are just meant for you to visualize some of the issues that current companies are facing, and just how DevOps solves that problem, because we're being paid to solve problems. If there was no problem, there will be no DevOps. So, for example, maintaining production environment uptime, you need good monitoring. Infrastructure automation, you want to have that in code, guys. Imagine every day you had to create just a basic Ubuntu server. You had to go in on AWS, which we're gonna go through AWS. But I'm sure a few people here have gone on AWS. You don't have to understand. You go in there and you have to click create EC2 instance. Create this. You have to click, and do all that thing. Each time you want to create, when the developer says, I need EC2, you go and you click. No, we're not going to do that. That's why we're going to do Terraform. Terraform, you're going to put everything in code, and each time you need a new EC2, you're going to run the same code, and it's going to bring up the same environment. You want to destroy, you hit destroy, and Terraform will bring it down. So everything is identical, and everything you can pretty much do that every minute. You can have systems coming up and coming down every minute. So that's what the DevOps will bring to you. And now you can continuously increase the number of servers using auto-scaling, right? So we're going to go into monitoring. For example, if something is hot, what do? You pour some water into it. So with our IT, if a system is hot, you have high CPU, what do? You pour more servers into it, right? So we're going to be able to see how we can automate that process. Well, as soon as the system is hot, which means the CPU is going higher, what? Autoscaling automatically increases the number of servers. You don't have to be there. Yeah, so yeah, we're going to go through all that fun stuff. DevOps is fun, man. It's one of the most fun jobs I've done. I've done DBA, I've done system administrator, struggled with that. But as soon as I got into DevOps, I knew this was where to be. Because in IT, it's so easy to get burnout. But with DevOps, you constantly work with different tools. You're so engaged that, it's so hard to use. If you actually love IT and if you love the money, you're going to love the job, man, because the job is fun. It's a fun job. So, yeah, so if you have difficult maintaining production and uptime, what do? You want high uptime. You want your system running at all time. If you have ineffective tools, system required, you need something that you can easily administrate. So yeah, we talked about this, guys. So that's all. Today is just going to be all conceptual, just try to solve some of the issues that DevOps will solve. And when you have that, you're going to get into the fun part, which is actually learning the actual automation. So this is some of the problems that the operations team. So if you guys didn't know, a development team, when they say DevOps, Dev is developers. So this is essentially what people call software engineers, right? These are the people that write the code. These are the people that change the websites. If you have Walmart, these are the people that edit the Walmart website, write the code, push it in, build it, and deploy it. And then the operations team, if you guys know, when you say ops, we're talking about database administrator, we're talking about system administrators, people who actually watch the system. We're talking about infrastructural engineers, people like that. That's the ops team. So DevOps is meant to bring those two teams together to solve the communication issues, lagging issues, blame game, all that stuff. This is what we're here to solve. So DevOps, when someone tells you about DevOps, there's one thing I want you to keep in mind. When I say DevOps, it's not the job title. DevOps is a mindset that you're bringing in. And what is that mindset? You're bringing that mindset of communication, collaboration. You're bringing that mindset of effectiveness, and you're bringing that mindset of continuous, speedy recovery and monitoring. So that you should, if you get in an interview and someone asks you, when they say DevOps, what do they mean by DevOps? First thing you want to mention to them is when you talk about DevOps, you're talking about a mindset, right? You have to tell that interview, you talk about mindset. DevOps is all about your mindset. You can go to a company calling yourself a DevOps engineer, but trust me, the biggest issues you're going to have is not changing the tools. The issue you have is changing the people. Guys, the issue you have is changing the people. Usually the people are the most difficult problems. You have people that just want to get stuck in their ways, right? Well, people are going to tell you, man, I've been doing this for too long. The same thing, it's been working, right? And some people, they're just like this guy. They don't want to, they don't want to have any more work than need. But you're trying to help them, but they don't want to understand that. So the biggest part of DevOps is the mindset, the culture. You're trying to change the culture of an organization. You're not just trying to come here and implement tools. You want to show people how those tools are going to help them, and you want to drive change. So if you get into an interview and someone wants to know how you understand about DevOps, you're telling them, I'm here to change the mindset of the company. I'm here to do a cultural change, because that's what DevOps is. You're changing the culture of the company. You're changing the culture of the engineers. You're changing the culture of the operations team. You're changing the culture of whoever calls himself your boss. You're letting them know that there's a different way of doing things, right? And that's the DevOps way, which means that continuous integration, continuous deployment, continuous monitoring, and continuous feedback. Those are the 4 big things in DevOps, essentially. Yeah, I'm taking a recording, guys. So if you wanna, I'm gonna post it, and we'll be able to go back, and if there's something you really wanna touch through, you'll solve. So this picture right here, I thought this was interesting. That's why I added it. So this is a regular camera process, right? You take a picture, you do your film development, you do your quality control. This was the old cameras, quality control. You deliver back to the customer, and then you wait for feedback. This right here is DevOps, but this is all a full continuous pipeline, right? You have a full pipeline. So when you take a picture, this is a developer essentially taking an issue into the system and working on it, right? When he's done with it, he ships that, which is the film development. He ships that into Git, which we're going to study Git. When he's done, there's quality control. And what is that? That's continuous testing, right? We're testing that code to make sure that code is running. That's quality control. And if something fails, what do? You're constantly sending feedback. If it's successful, you send a feedback, right? You send an email, you send a Slack to your team, to a group. You might have a group for developers. You might have a group for deployments. You send a feedback saying, oh, deployment was successful. If it failed, you send a feedback saying, oh, it failed. And you're sending continuous feedback to customers. And then when you have a very late, oh, this one says very late customer feedback. Yeah, in DevOps, we don't have very late customer feedback. You want to be always talking to your customers. And believe me, as a developer, most of our issues that comes in, they come from the customers. So the customers are your friend. If I, for example, if I go on Walmart right now and I was trying to do a checkout, and let's say I added something to my cart, right? And I tried to check out and it failed and I couldn't check out. What do I do as a customer? I'll probably send a feedback and say, I tried to check out, right? And the checkout wasn't working. You know what happens in the back end? Automatically, what happens is a ticket will be created, right? On this platform called Jira. It's just a ticketing management system. We'll probably talk a little bit about Jira just so you're not surprised. So a ticket will get created for checkout. Someone's going to create a ticket and say, oh, checkout, the customer complained about checkout. He's going to put that ticket in our Jira. Well, a developer will pick that ticket up and he's going to start working on it, right? When he finishes working on it and he tests it on his local, he says, oh, now I'm able to check out. He's going to push that code into Git. And then automatically it's going to get built, right? The code for the checkout will get built and will be deployed to a test environment. Now, when it goes to that test environment, what we're doing integration testing. We're doing functional testing. And we're making sure that that checkout issue that we had is being fixed. Once everything is validated that checkout was fixed, it automatically gets deployed to walmart.com. And now customers can go back and check out and say, oh, now I can check out. So we solve a customer's problem and now the company can continue making money. Back in the day, that thing will probably take 3 months, even 6 months, just to put that simple change. And you can imagine how much you're going to lose. But now with DevOps, you can pretty much fix and deploy a code within minutes and you have that thing live. That's why DevOps is so effective, guys. And that's why, every company in the world needs DevOps. You go online, NBC needs DevOps. You go online, even NBA needs DevOps. Startups, they need DevOps. Every company in the world needs a DevOps engineer. The market is just too much. So, guys, we're going to have so many jobs coming our way over the next few years. There's positions that have been open for a year, and no one can fill it. So you're going to find your own position, guys. If you just understand the concepts, and like I keep saying, every company needs a DevOps. Some don't know it, some know, some don't even know what they want, but they're out there looking for DevOps. There's just so much demand for this position right now. And this is some most common misunderstandings, right? Like I just mentioned to you guys, DevOps is not a role or person or organization. DevOps is not a separate team. DevOps is not a product or a tool. DevOps is not just about writing scripts or implementing tools. Remember, I told you guys, DevOps is about mindset, cultural change, bringing change to an organization, improving the way they do things, accelerating production, release. That's what DevOps is. It's not a role, it's not a person. So if you go to interview, guys, keep this in mind. If you're going to go to an interview, you don't want to go refer to DevOps as a role or as a person. I told you, it's not a job description. People say they're looking for a DevOps engineer, but what they're looking for is they're looking for that cultural change. That's what they're looking for. They're looking for that acceleration, that speed, that CIC, that speed of delivery. That's pretty much what DevOps stands for. Development and operations, bringing them together. So keep that in mind, guys. I've seen people interviews that have asked this question, and it seems like an easy question, but it's a trick question. Because they're expecting you to say DevOps is a position where you do this and that. And then they'll be like, oh, okay. This guy really doesn't know what we're looking for, doesn't know what DevOps is pretty much. So keep that in mind. DevOps is not a role, it's not a person, it's not an organization. It's not a separate team, it's a mindset. You're bringing two teams together, using your pipelines, using your skill sets. You're improving the company's feedback, you're improving company's delivery. That's what you are. You're not a position, you're like a culture, you're like a game changer pretty much. You're not a role. DevOps is not a role, guys. It's a mindset, it's a cultural change. That's what it is. Keep that in mind. and you're going to sound very smart in an interview. Once you tell them DevOps is a mindset, it's a cultural change, they don't want to hear anything else. You're done. That's all they want to hear. Yeah, so we're going to go through this. I think in greater detail. This Zoom thing just blocks everything. So this is a 5-step journey that we're going to go through as a DevOps. So like I mentioned to you guys, it's a cultural transformation. I'm going to keep emphasizing that, guys. DevOps is a cultural transformation, right? It's a process transformation. It's a tech transformation. It's an automate everything, and it's an adoption of tools. So as you can see, just from looking at this, you can understand that DevOps is not a role, guys. It's a complete process of, when you go and you do a facelift, when you go and do a facelift and you swap your face for another face, that's what DevOps means. You're changing the entire process. You're changing the game. You're changing people's mindsets. So this is what DevOps is. Don't get caught in thinking that, oh, my DevOps engineer is a job. It's not, guys. If you go looking at it as a job, you're going to face a lot of problems. So this is kind of what the old school was. Waterfall model. You have the design, you have the code. You see, the code takes the longest amount of time. People write code. I've seen companies write code for 3 to 6 months. And when they start testing it, they're going to face all kinds of problems because think about it. I want you guys to really answer, if someone can really answer this question, right, guys? Which is more effective? To put 20 things in one, test all that 20 stuff at once, and then deploy them, or to do the first thing, test, deploy, the second, test, deploy. Which one do you think is more efficient and is more error prone, guys?
Second one for sure.
Test and deploy, test and deploy.
Yes, to build test, right? In little chunks. Guys, that's the way to go. Because guess what? Yeah.
I was going to say, that makes perfect sense because if you're testing and deploying, then you're seeing the mistakes in real time.
Exactly.
20 things, and those 20 things could give you 40 problems or even 60 problems. Exactly. And then now you don't even know where to start from. So
you don't even know where to start, exactly. But if you push one thing and you can test, you can exactly know, okay, this is a problem, right? How complicated is it? I push one thing and that okay, that's the problem. But if you have 20 things that you're working on, like now you're like, oh, now you have to do all kinds of troubleshooting. You have people sleeping overnight. You have disgruntled employees because they have to stay all night. I've had deployments that I had to stay all night till morning, guys, just trying to get change into production. And then we're going to end up rolling everything back to the old version and go back to square one. Yeah, that's waterfall, and that's even agile for you guys. And this is agile with continuous deploy. This is kind of what DevOps is. Test, code, test, deploy, code, test, deploy, code, test, deploy. If the code fails, you send it back. And while you're sending that back, another developer could be working on something completely different, right? Because we can track every change in GitHub. You're not going to measure anything if it fails to master. We're going to disapprove it. The code is not going to merge. So guess what? You still have a working tree that another developer could pull it out and continue working on it and do his thing. He could be working on something else and still be able to push it to production, even though your own failed. But if you have that waterfall model right there, if one guy fails, the entire thing fails. Yeah, so you see why DevOps is such a creative way of doing things, and why DevOps is so in demand, and why companies are willing to pay so much money for it. This is why, guys. It's something different. So, yeah, this is more visualization. I think visualization really helps. So waterfall, you have this one big monolith. And guys, if you don't know what monolith is, a monolith is basically one thing that has all kinds of things running in it. So if one thing breaks in the monolith, you have to bring the entire thing down to fix it, right? That's what a monolith is. And usually that's what most companies used to have. They still have those. And then you have an end tier, which is an agile, while you could have maybe something decoupled. You could have a database completely separate. You can have your front end completely separate, and then you can have your middleware completely separate. But at the same time, if one thing breaks, guess what? You still have to almost put everything down. And then you have DevOps, which mostly is microservices. And you know what those microservices run on? They run on Docker images. And those things are so light that you can move them from one part of the world to another in seconds, right? And then you have microservices. Those Docker images, we're going to work with containers and Kubernetes. And you're going to see how you can take one service and run it on Kubernetes and run multiple services. And guys, those services are going to be talking to each other using something we call API, which we're going to talk about right now. Not right now, but we're going to talk about when we go deeper. But guys, the goal of microservices and DevOps is, if I have my checkout system, right? Let's just say a microservice, let's just say we have an infrastructure like Walmart.com. Walmart has the front end, right? They have checkout. Checkout would be a completely different microservices. This was DevOps, right? And then you're going to have your sharded, your database, right? And then guys, you're going to have other things. You're going to have promotions. It'll be a separate data service. You have fulfillment, which is where the orders get fulfilled. That'll be a complete microservice. So guess what? If fulfillment goes down, or let's just say checkout goes down, everything else is still running. The only thing is customers won't be able to check out, right? But they'll be able to do many other things. The entire system doesn't go down, right? If a database had issues, customers will still be able to, browse, be able to send in their orders, but they're just not going to be able to fulfill their orders in the database. So now you have this flexibility where one thing goes down, everybody's not just running left and right. You can just have someone build. If checkout goes down, you can fix checkout, push it in, and it can be deployed, and then checkout is up, and then everything continues running like nothing happened. So that's basically and we're going to do all that in the cloud using Kubernetes. And you're going to see how Kubernetes can do that. Most of these things are going to sound like rocket science, but once you start doing it, you see, guys, that this is all easy stuff. People are just calling names left and right, Kubernetes, Docker, all these big names, guys. It's just basically tools that have been simplified for that anybody can use them. But if you don't know, you think it's some kind of rocket science. It's not. I'll tell you that. So this is kind of the adoption curve. I know this is kind of old, but you can see the adoption. I tell you, there's always people that don't even know what DevOps is. And you'll be surprised, guys. Those people that don't know what DevOps is, they still go around hiring DevOps. So many companies they don't even know what DevOps is, but they'll go around hiring DevOps. But basically, they're hiring a system, they're looking for a system administrator, but they're hiring DevOps. Company-wide, 21%. Those not adopting, 12%. Adopting DevOps for project teams, 29%. And then adopting DevOps for BUs and divisions, guys, 31%. This is just a start. The adoption, like I keep saying, guys, is going to keep going up and going up and going up. And this is some of the tools that we're going to work with, right? So I know this seems like an essay, but guys, the more you keep familiarizing with these tools, when we start doing them individually, you're going to understand. So we have version control. So I'll say version control, when we start working with it, is where you put your code, right? If I put my code in version control, if I'm in the same organization with, say, Zampa or Urek, if I put my code in version control and Urek has an access to that repo, he can pull that same code, he can work on it on a separate branch, and he can push it back, right? And then he can create something we call a pull request, which we're going to see. And then I can go in there and look at the code and make sure that everything is working. Everything looks good. And then I'll merge that code into the master branch, and then it triggers a pipeline. So that helps to make sure that people are not doing things in silo, guys. Just make sure that I'm not sitting in my house, just touching code and then pushing it into production. No, we need to have everything where in a central position where people can see them. Everybody can follow. Changes can be monitored. Changes can be tracked. Because if something breaks, guess what? I can just go back and roll the previous change that Zampa did and rebuild it, and then it works, right? So we have everything tracked. So that's pretty much what Git is. Git is a game changer, guys. And it's so easy to learn. But once you start using it, you see how smart. And you know who wrote Git? It was the same guy that wrote Linux. Yeah, he was the same guy that wrote Git. Because he saw the problems that developers were facing. People used to take codes and put in a local machine, they'll make changes, and then they'll deploy it. And another guy will have his own code, separate code, and he'll deploy it, and then that was just going to break the system. So that's why he came up with Git. And now every company that does DevOps, you need Git. You cannot do DevOps without a version control system. It doesn't have to be Git. Some companies use some other system, but they're all version control. They all track every version of the code. Continuous integration, Jenkins, GitLab. We use GitLab, Jenkins. We even have some called Spinnaker, guys. There's so many tools. But what I'm trying to let you guys understand is understand the concept. The tools doesn't matter. Once you get the concept, you know exactly what that tool is supposed to do. Now you can go out there and pick out any tools and be able to do what you need to do with it. Now there's another one called GitHub Actions, we're using the same Git. But what happens is once you push code into Git, Git triggers a build and Git even deploys it for you guys. That's what most companies are driving to because it's easier than actually installing Jenkins and all that. You don't need that. You just need one Git server and you can be able to deploy. So I think I'll talk a little bit about GitHub Actions because some companies might bring that up in an interview because so many companies are using it, but it's so much easier, guys. It does the same continuous integration and it does the same continuous deployment. But then you just have to use a version control like Git and you're able to deploy. Virtualization and containerization, Docker. We're going to talk more about Docker. I think that will be a fun topic, Docker and Kubernetes, orchestration, the kind of problems that solves. But I can tell you right now, guys, before, when we had Ubuntu, you want to install Jenkins, guys, you go build up a big, bulky server and you install Jenkins on it, right? And now you just have resources being wasted, things that you don't really need. You have lib files. When we start doing Linux, you see the Linux operating system, how it works. You see so many things on that Linux server that you don't really need. That's what Docker solves. So now, guess what? I want to run Jenkins. What do? I just pull out the Jenkins image. I could pull out the Jenkins image right now and run the Jenkins server. And all I have is that image that has Jenkins on it. That's Docker. That's the power of Docker. And I could finish that image and I could send it to Zappa. And Zappa could run the same thing and have the same Jenkins that I had. So that's what Docker, and then Kubernetes is pretty much orchestration. I know people confuse Kubernetes, they think Kubernetes and Docker is the same. It's not. Kubernetes is what orchestrates Docker for you. So where do I deploy Docker? How can I manage Docker? How can I make sure that my Docker is reliable? That's what Kubernetes will do for you. Microservices, that's what Kubernetes will do for you. Config management. Essentially, another thing, guys, is when you're deploying code, let's say you're doing a regular server, HTTP, or just an HTTP server, or I don't know, HTTP, anything you're running, right? Sometimes you need dependencies, right? I know some of this is going to sound a little bit, but once we go into it, I promise you guys, once we go into it, you understand. But applications need dependencies. For example, Jenkins. You cannot run Jenkins if you don't have Java. I know a lot of us know what Java is. You cannot run Jenkins without Java. So you have to install Java before you even install Jenkins, right? That's a dependency. So Java is a dependency. Yeah, it is a dependency that Jenkins needs. Many other application guys, they have so many dependencies. So how do I make sure that when I deploy my code, guys, the system is ready? How do I make sure that when I deploy my code, the system, if you needed Java is already installed, right? If you needed Git is installed. If you needed anything that it needs, it's already been installed before it, so my application can just run seamlessly. And not just that, so my application can be identical every time I run it. That's the key with DevOps, guys. Because if you run an application in a system that's different from another system, it might fail, right? And you'd be like, oh, why did it fail? But if you have identical systems with identical dependencies and the same versions, identical versions of those dependencies, you're pretty much sure that if I deploy this code in my staging environment, my test environment, if it passes, it will pass in production because production is identical to my staging. That's the goal. And that's what configuration management will do for you guys. Configuration management, what you do is you put your dependencies in that configuration management tool and you deploy it. Guess what? It goes in there and it makes sure that the system has all the tools that it needs, the specific versions. So now when I deploy my code is ready. I don't have to do anything else. So you see how important that config management is, guys. It's a big, we're going to talk about more why config management is starting to really being underused, which is a good thing because they can get complicated. Ansible is easy. Puppet can get complicated. But now with Docker and Kubernetes and Helm charts, now people are starting to use those less and less and less and less, which is a good thing for us. I'll tell you that, guys. It's such a good thing for us, especially new guys coming into DevOps. You don't want to have to be dealing with that stuff. Monitoring Prometheus. We're going to use Prometheus and Grafana, but this is so important as a DevOps engineer. You want to have visibility, right? And we're going to install, for Prometheus, we're going to install Prometheus agents. And then what we're going to do, guys, is we're going to install something called Prometheus agents on our Kubernetes cluster. I'm saying this because I know it sounds like, but it's agents that you deploy. And then guess what? It's going to get data from your system, how your system is running, and it's going to feed those to Grafana as a data source. And then with Grafana now, you can create, it's called Grafana, you can create beautiful graphs about CPU and other stuff. And you can create alerts, right? So you can sit in front of a computer and you're looking at Grafana, and you can see the entire picture of your system, right? You can see if the system is struggling. That's what you need. If you can have good monitoring, it makes your life so much easier. I'll tell you from experience, guys. If you have good monitoring, It makes your life so much easier, especially when you're troubleshooting and things like that. So scripting, we're gonna do Bash. We're gonna do a little bit of Bash when we're doing Linux. So this is one of the first scripting we're gonna do when we're doing Linux. We're gonna do a little bit of Bash. You'll see how Bash works. It's easy, guys. You don't have to be too complicated with Bash. Bash is so straightforward, and you guys will see how. We're gonna do Python. We don't have to worry about Go, Node, all those. They all do the same thing. Infrastructure as a code. Remember, I told you guys, you don't want to keep going there and clicking and clicking and clicking and doing the same thing over and over. You want to put it in code. So you can easily run that code and just bring up the same environment every single time. That's what Terraform will do for you. And then cloud platform, we're going to work predominantly on AWS because AWS is the big guy, is the number one plan. Okay? And how do you do that? You use a system that pretty much every company I've worked with, guys, they use it. It's called Jira. You can write it down somewhere. It's not rocket science, so you don't need to go and try to learn anything special about it. But essentially, it's just a ticketing management system where if there's a bug or any kind of thing in the system that you need to work on, you just create a ticket so you can track it, right? So that's what it pretty much does. I know Trello is here. No one cares about Trello. You want to worry about Jira. You see this icon right here at the end? This is Jira. That's the one that 90% of the companies have used. They've used Jira. So when you have that idea, no one's going to come to an interview and ask you, okay, what is Jira? What does Jira do? What does it do? Or things like that. But if you're explaining a question to someone, right, you want to mention to them that, oh, guys, when we were working on that project, the project got created in Jira. And once you have to bring things that you know into your interviews, guys. I'm going to keep telling you this. Always bring things that you know. Don't wait for them to ask. And that's how you control interviews. From now, as we go along, I'll keep talking about interviews just so you guys can keep getting your mind ready. You have to know how to control interviews. And how do you do that? You take a question and you extend it and you add things that you think might relate to that question, right? If someone asks you about planning, how do you deploy code? You can start from Jira, talk about Jira, and then talk about Jira, and then you can go to the next thing. So that's kind of how you drive interviews and you control interviews and you show these guys that actually I know. Because when they come, they're asking you what they want to ask you, right? But there's so many things that you know and you want to show them. How are you going to show them? When you ask me something, I'll answer it and I'll tell you more and even tell you more about other things that I know that can relate to that. That's how you show people that you actually know what you're doing. And you actually, so all what you're learning, you can actually put that into use. So you need to plan, track, visualize, summarize. And what do you use? You use Jira for that. You don't have to worry about anybody asking you about Jira. I've never been asked about Jira in an interview. But when you bring it up, they know this guy has been working, those are one of the things that you just keep in mind. And then there's the second one. There's the code stage, which we've been talking about. That's when the developer makes that changes to the code, right? It could be the Walmart checkout code. It could be the Walmart fulfillment code. When he makes that change, right? That's the next stage. He makes that change and he's going to do all that through GitHub, which we're going to study how to use GitHub. That's the second life cycle. That's very important, guys. You plan on Jira, you pick up that ticket, start seeing how the steps are. A guy writes a ticket, he puts that on Jira. The developer picks that ticket up, right? Guys, those are the steps. What does he do? Now he starts working on that code. That's what we're working on now. And then guess what? Next, what do? He pushes it into GitHub. And what happens? You build that code, right? That's the second stage of your pipeline, right? You can use, Gradle, you can use Maven, all this you don't have to worry about. Most of the companies you go with, they already have a build tool. All you have to do is integrate that into a pipeline. Most of the companies you go, they already have a pipeline. All you have to do is what? Improve them. So don't think you're going to go there and try to do any kind of magic. It's already there. That's why I keep telling you DevOps is a mindset. People are going to have tools, but they don't know how to use it. People are going to have the system, but they're not implementing right. So now we have the build stage where when the code goes into GitHub, someone builds it. Because trust me, guys, every code you see out there has to be built. Especially if you're using Java. Java, you have to compile. You have to build. Every code, NPM, if you're using Node.js, you have to build. If you're using AngularJS, which is a front end, you have to use NPM to install, which is just a one-line command, which we're going to do with Linux. But guys, everything has to be built. Everything has to be packaged so it can be ready for the operating system. It can be ready for the system to interpret, pretty much. What's the next stage, guys? Testing, continuous testing. So we're going in that progressive step. So we go from plan to code to build to test. And what do you guys, what do you think we have next after you test? Well, guys, what do you think after you test the code?
Do you implement it?
Pretty much. I mean, that's a release. You release it, right? I mean, it's not okay. It's so easy, guys. I mean, that's pretty much it. We're going to do the tools, but yeah, that's the pipeline. I mean, you release it. I mean, what else are you going to do? If nothing else breaks, you release the code, guys. And then that's Jenkins. We're going to use Jenkins for that stuff as well. And what do we have here? Another stage, deploy, which is still the release. Because before you deploy something, you have to test it. And when you're testing it, you deploy into test environment. And then once you create a release, when they say release, what they were talking about is this is what's ready for production, right? That's a release. When you do every testing and your code is ready, you say, okay, this code has passed every test and is ready for customers to start consuming. Now you have to deploy it. So you create what we call a release branch, usually. You see that in GitHub, you create a release branch, and that's what you're saying that this is what is going to go live, right? And then you deploy it, guys. So that's it. And then, everything is getting operated. The operations part is, what, just making sure that the system is working on top, the dependencies are there, there's nothing missing. And then this is the most important one, guys, monitoring. And the good thing about monitoring, and the most important thing about monitoring, guys, is it seems like it's at the last stage, but you monitor at every stage. So that's why they call it continuous monitoring. So even if when the developer pushes into Git and you're building your monitoring, when you deploy into stage environment, you're monitoring. So you can see changes. When it's in production, you're monitoring. So you have to continuously monitor. That's why monitoring is so important, guys. As a DevOps engineer, you have to always bring these things in the interview. You have to let them know that you take monitoring seriously, because that's so vital to be a good DevOps. You have to make sure in interviews that you take monitoring very seriously. People underlook it. Trust me, so many people underlook monitoring. This is what about code, build, deploy, things like that. But monitoring and feedback is essentially what's going to make your company improve. Take that next step. That's the key to improvement, is continuous feedback. Tell the developer, this was a bad code. This is what happened. Next time, this is what you got to do, right? Continuous feedback. That's what actually brings change. It's not just deploy. And you can deploy. And if someone doesn't have feedback, and if you're not seeing the systems, seeing what the systems are telling you, you're not really going to improve. The company is not going to grow. So this is very important. Yeah? And this is we're back to the first stage. I'm keep hammering these points home. So when we get into the practicals and things like that, everything is familiar. We're back to version control, GitHub. You can see it's the first stage, right? You see our 3 developers here, guys. They're working on the code. Good thing is, guys, you don't have to worry about the code part. That's developers. You're the DevOps engineer. So many people, they're so scared about DevOps. You know why? Because they think that they're these people right here. Guys, you're not. These are developers. This is what they get paid to do. And they do this 24/7. All they do is write code. That's not you. Don't be scared. That's not you. These are people. Their job is to write code. So never think that DevOps is about the guys. This is not your job. That's developer's job. You're there to make this guy's life easy. Keep that in mind. When you're doing interviews, guys, you're here to make the developer's life easy. So when you go to an interview, you're letting them know, this is a cultural mindset to make my developers' lives easier. That's why you're a DevOps. Because those are the guys that write the code. You're trying to make their life easier. You're trying to make deployments easier for those guys. Keep that in mind when you're talking about DevOps. You're trying to keep your developers happy because they're the ones writing all that code. You don't have to worry about that. So first is your GitHub, which first is version control. And then once you're done, your code is in version control. This is basically, I know we've hammered this home, but guys, if you had any doubts, this is basically what is trying to explain what I know I've said this, but you can go through this real quick, and it tries to explain to you what version control is. I know I see Zampa is looking. Yeah, man, you got to, man. So this is what version control is, guys. As I said, the records changes, and things like that is very, very important, guys. I can't emphasize. There's no DevOps job that doesn't use Git. There is no DevOps job that doesn't use a version control. Git is very important, guys. It's easy, but what it does, you cannot do DevOps without version control. Continuous integration. That's where Jenkins comes in, guys. Continuous integration, when you say continuous integration, it's a fancy word, but what it's just telling us is when I push code, it automatically triggers a build, right, guys? That's continuous integration because you're continually integrating your code, right? without any manual intervention. The code is just a pipeline. It's running. It's integrated. That's what I mean by continuous integration. So when you see CI/CD, when you see CI continuous integration, it's just a pipeline. It's continuous. Any code that comes in, it builds it. Any code that comes in, it builds it. That's continuous integration. That's what they're trying to mean when they say continuous. Each time a developer pushes, we build. Pushes, it build. If it fails, notification to the developer, your code failed. Can you fix it? Each time a code comes in, it triggers a build. That's continuous integration. You gotta hammer that home. You know, this is exactly what it is. You continue integrating, detect errors quickly. Exactly, guys. That's DevOps principles. Continuous testing. We've talked about that. You have a QA team. You don't have to worry about this, guys. You have a QA team. Every company I've worked with, they have a QA team that write the test cases. So let no one scare you and say, oh, guys, you have to write test cases. No, you have a QA team that does that. Automated, so that's not even your job, guys. DevOps is not that complicated. You can imagine testing, you have a QA team doing it. Cool, you have developers writing it. Your job is just to connect the dots, and we'll see how you can do that. But guys, you know, people just don't have the knowledge, guys. I think what's lacking right now for DevOps is there's not a lot of training out there. The people that become DevOps are mostly developers that grow into the role because there's not a lot of training. So people don't really know what's going on, but it's not that complicated. Anybody can be a DevOps engineer. I became a DevOps engineer, and what was I doing? I had no IT background, guys. Anybody could be a DevOps engineer and be a really good one. This is continuous testing. Yeah, we've talked about this. You know, continuous deployments. Jenkins will do the same thing for you. You can use another tool if you wanted to. We're gonna go through AWS tools like code deploy, code build. They all do the same thing as Jenkins. But it's good to familiarize yourself with those tools. They'll deploy. Jenkins will deploy to Kubernetes. Jenkins will deploy anywhere, you know, and then you have, and I need to go back. And guys, do you see the monitoring? You see that monitoring covers the entire thing? Because you have to continuously monitor and send feedback. Continuously monitor and send feedback. Yeah, we've been hammering this home, guys. It's just conceptual, but guys, keep this in mind. This is what DevOps does. The more I keep hammering home, the more you keep understanding what DevOps does. All that misconception, guys, take it out. DevOps is not rocket science. You know, we're gonna see that as we work with DevOps. Configuration management, we talked about that. We're gonna use Ansible to make sure that dependencies are always kept in place. Dependencies are tracked, right? Every system has the same dependencies. Whether you're bringing up a system now or you're bringing up in the future, it has all the dependencies it needs to run. That's configuration management. Once we do Ansible, guys, you see how easy it is to manage dependencies. You know, all this sounds like rocket science, but once you start doing it, you see how easy it is to package your dependencies and manage them and just keep doing the same thing over. You're pretty much just running the same code on every new environment, guys. You're running the same set of, you know, configuration codes on every new environment you build, and it just brings it to that same state that you need. And you just deploy them. You know, there's so many automation out there, guys. We're gonna definitely do Ansible. We're gonna see how Ansible is so easy. I think you guys are gonna pick it up. You know, once we understand, trash out a little bit about YAML, you guys are gonna pick up Ansible pretty quickly. I really think it's very easy. And you could use Ansible for so many things. So let's talk a little bit about containerization.
Can I jump in real quick?
Sorry. Yeah.
Yeah. So you made mention of it's just like you're sorting through different codes that are being sent from the developer, and then you're looking to see if there's an error. So what if you detect an error, and would you be able to, like, you know, look through the code to see if you can do it first before sending it back?
Well, if you get paid extra, you can do that. But trust me, Felix, once you see an issue in the code, if you wanna do it, you can do it. But you know, that's what the developer gets paid to do, bro. So he gets paid to write good code, and if he writes a bad code, he has to fix it. You know what I mean? And as a DevOps engineer, that's the kind of authority you want to stamp out. You know, you want to make sure that people are not just writing good code. But if you fix it, what do you think he's going to do next time? He's probably just going to keep writing stupid code, right? Because if he breaks, this guy's going to fix it. You have to send it back to him and let him fix it. The more you fix code, guys, the more he's going to start writing better code. How is he going to improve? You know? So yeah, whenever you detect an issue, you have that developer fix it, fix what you spoil. You know,
Oh,
I
okay.
mean, that's pretty much what you get paid to do. I mean, what else do you do? That's all they do, guys. They just write code. You have so many on your plate, so many things on your plate. You know, the last thing you want to worry about is fixing someone else's job. you know, Felix. But yeah, if you do have the capacity and you want to do that, by all means. But I, as an engineer, I'll never do that. You know, I'll just send it back to you and you fix your problem.
So put those in the cars.
I have a quick question, so if you don't mind.
Yeah.
We talked about dependencies earlier, and you said Java, for example, may be a dependency. If you have to run something on a computer that needs Java, that counts as a dependency. Sometimes, if you're running a program on one system that uses Ubuntu, for example, and you have to deploy it on another system that uses, let's say, Linux, does that count as a dependency as well, or it doesn't matter?
Yeah, it does, but no, it kind of does. But there's one thing I'll tell you: with Ansible, right? You can do something we call operation conditioners, right? And what are those conditioners? You're telling Ansible, guys, Ansible is so smart that you can tell Ansible that if this system is a CentOS, right, install Apache. If this system is Ubuntu, you want to install HTTPD. It's the same thing, guys. It does the same thing. But because we're talking about two systems, they have different names. Not a lot. Usually the names in Linux, they're the same most times. But you have cases like that where you want to deploy a simple web server. And on Ubuntu, it's called HTTPD. And on CentOS, it's called Apache, right? Apache 2. Right. So you can have Ansible be able to check that OS. Something Ansible does is called gathering facts, right? Once you let Ansible gather facts, Ansible will know everything about that system. So now, yeah, you just tell Ansible, if this is a CentOS, you want to install, this is a package that's supposed to do this. Guys, Ansible will handle it for you. Yeah, guys, Ansible is something else, and it's not that complicated. Yeah, guys, that was a good question, though. Yeah, containerization, guys. This is an important thing. We're going to do containerization when we talk about Docker. But essentially, it's what it is. It's a container. So think about, I talked about Python. Right now, if you want to run Python, if you have a Python code to run on Kubernetes, guys, how do you think you're going to do it? You can just pull a normal Python image, right? You don't have to go build a whole server and install Python on it, or you don't have to install Python on your laptop. I can just pull a Python image, put my Python code in it, and just deploy it, and it's going to run, right? That Docker container only has Python on it and all the dependencies you need. So that's the container, because it contains just your Python now and all the Python code that you need. You can say it with any other application, right? If you want to deploy an application using Docker, Docker essentially just packages everything in one and only the things you need. So, for example, if I don't need HTTPD in my system, I don't need to have it. But if you go to a normal, when we start working on the cloud, and we go to a normal Ubuntu server, you're going to see millions of things already installed on that server, right, guys? You don't need all those millions of things. You know, if I only need Jenkins and Java, I only need Jenkins and Java. So imagine how simple and how small your container can be if you only had what you need. And that's why containerization is so important, guys, because you only get what you need. Like, for example, you have your laptop, guys. Tell me how many applications are running on that laptop. A normal server has so many applications running on them. But if I only need, let's say, my VS Code, right? And that's something I'll have you guys install when we start working with Git. We just need to start working like professionals. You know, the tools that I use, I'm going to make sure that we guys install them in your computer and start using them, you know, so you start familiarizing yourself. But guys, if you wanted to run an application on your machine, let's say you bought your machine and all I wanted to do was go on the internet, right? Your computer will be so light, it'll probably be, you know, this way, you know, because all you need is a browser. That's it. And connectivity to the internet. You don't need all these million things that you have on your machine, right? So your computer will probably be this light and this small. That's exactly what Docker does. If I only need Jenkins, why do I have all these applications running, right? Why do I have all these video applications? Why do I have all these million things running? So that's the problem that Docker was able to solve and makes things move really fast. So that's why, you know, as a DevOps engineer, you want to know how to use Docker. And we're going to learn that. It's not rocket science, guys. It actually makes things a lot easier. It makes things so much easier. Ever since I started using Docker and Kubernetes, my life as an engineer has been so easy, guys. You don't even need to use a lot of configuration management anymore, guys. Docker, they're here. Don't get scared. They're here to make your life easy. They'll make your life as an engineer so easy. You're gonna be cruising through stuff. Continuous monitoring. We've hammered this home. You need monitoring. I can't emphasize how important it is. How much I've gotten out of trouble because of monitoring. If you don't have good monitoring, you don't know what's going on, guys. You're pretty much lost. I have one of my companies. I have a boss. He's like he has no monitoring. He doesn't know what's going on. Every day he's asking about updates. What's going on? What's going on? That guy he needs monitoring, guys. You don't want to be lost because that's how you lose the organization. That's how you lose confidence from people because you don't know what's going on. Something breaks. Oh, you're running left. You're running right. You're running left. You don't want to do that. You want to just go to your monitoring and even see it before it happens, right? Stay on top of your game, and it's not that complicated. You just need to set up simple monitoring, guys, and it's so important. I'm telling you, that boss right now, the whole team, we don't respect him. When he talks, we're just like, the fuck, because he doesn't know what's going on, Guys, you want to always know what's going on. You want to be on top of your game, and that's what monitoring is going to do for you. If you go to a company, you want to look at it monitoring first before you even look at any other thing. You want to keep your eye on the monitoring, because, people, when everything is going fine, no one cares. But one thing breaks, that's where you start seeing people calling you from left and right, man. People you never knew about, they're going to start texting you. So you want to be on top of your game because that's where you get exposed. You could sit 1 week, 2 weeks and do nothing, guys, and be just chill and not have any issues. But when one thing goes wrong, you could go for months. One thing goes wrong, and if you're not able to jump on top of it, now people are saying, okay, man, but what are we really paying this guy, man? Like one time that we have an issue and he doesn't even know what's going on, things like that, it matter. So monitoring will be a friend. Build unit tests, deploy auto tests, deploy to production. This is essentially it, guys. This is our pipeline. This is what we're focusing on. But I'm going to tell you, most companies that you're going to work with, they're trying to get to this stage. They're trying, but they're not there yet. So if you know where they're trying to go, it helps, right? Because now this is what they're trying to achieve. They don't even know what they're trying to achieve. That's why they're hiring you, right? But you have the end goal. You know that this is how DevOps is supposed to be done. You need a pipeline. You need continuous integration, testing. So when you have that in mind, you could sell yourself in an interview. I said, I built this. This is what I built. I built continuous integration. I built continuous monitoring. This is how I did it. And they're like, oh, man, this is the guy we need, man. We're in trouble, So, guys, that's basically it, man. I'm happy we're able to go through this conceptual stuff today. I think next class, we're going to probably start with Linux. And maybe just installing Linux will be it on your local. We're going to install Linux, and then we're going to install VirtualBox, and then install Ubuntu. And then we're going to play around with it and start doing some basic commands in Linux and start, seeing the power of Linux, why Linux is so much better than whatever we have, our Windows systems, our GUI. Linux, there's no clicking, guys. You're going to use everything from command line. So you're going to look like a professional, because once you open a Linux terminal, no one knows what's going on, But you as an engineer, or you've been working through Linux, it's easy. So we're going to go through Linux commands, and I'm going to create a page. Every command that we use, I'm going to type it on that page. Every command we use, I'm going to type it on that page. And then I'm going to share it. So if you're going back and trying to review, you can see all the commands that we've been using. And I think that would be really helpful. So guys, that was it for the concepts of what DevOps is. Guys, if you have any questions, here I am. Throw them at me, guys.
Yeah, hello?
Yeah.
Mr. Linux.
Yeah.
Yeah, Badger. So
How's your money?
Yeah. So you were talking about build. So when you talk about build, that part concerns just the developers, right? So you basically taking up from testing and deploying. Is that what your job is all about as a DevOps engineer?
So what happens is, as a DevOps engineer, when a company hires you, for the most part, right, that's what they're thinking. Big picture. They're thinking, okay, you're going to build a pipeline to build, test, and deploy our code, right? But the actual job is going to be so much more in terms of, okay, where are you going to deploy that infrastructure? You know what I mean? Where are you going to deploy that code? You need an infrastructure. So as a DevOps engineer, automatically you take up infrastructure. Okay, Docker, where are you going to package that code? You know what I mean? So automatically, what do? You need Docker. Where are you going to deploy that code? Okay, you need Kubernetes. So even though it says that it's build, test, and deploy, but there's so many other things that you need to deploy. You need Docker, you need Kubernetes, you need a pipeline to build. So it kind of expands a little bit, but the concept is, as a DevOps engineer, that's what your mindset is. That's what you have to do. How you do it, that's a whole nother question. And I promise you, no two companies are the same. No two companies I've worked with have been the same. So we're going to learn the entire concept. And when you go to your company, you're going to see that they're mixing and maxing something else. I've been with the company that was mixing Jenkins and AWS deploy. I've met companies that are just using Jenkins. I've been with a company that's using Jenkins and Spinnaker. I've used a company using GitLab. So how you do it,